Hello and welcome to another video. In this video we're going to be working on different ways to add parentheses. And in this one you're given a string expression of numbers and operators and you want to return all possible results by computing all the different ways to do this. And you can do it in any order, and yeah. And so for example here you can either do 2 minus 1 first, and then you'll get 1, then you can subtract 1, you get 0, or you could do this, which will give you 0, and then actually negative 1 minus 1 would give you negative 2. No. 1 minus 1 would give you 0, and then, yeah, because you don't have negative numbers here, so 1 minus 1 would give you 0, and then 2 minus that would give you 2. And here you can do a bunch of different things as well, and they show you the parentheses. So the important thing to note here is there's only 20 numbers, and then there's all this stuff. So because there's only 20 numbers, basically you want to figure out like what's the problem asking, and do I need to figure out where to put parentheses, or what do the parentheses actually do? And so what the parentheses actually do is tell you which of these things you do at what time. So for example, if you have this first thing, minus 4 times 5. So you can basically do any one of these operations first, and then get that result. Let's say we do this. And then you can do some other operation, and then you can do some other operation, and then you can do some other operation. But the idea is, how do we divide this into subproblems? And the way we can divide it into subproblems is pick what operation we do first. And so let's say we choose to do this operation first. This minus. So what we can do is we can say like, okay, well, actually, instead of doing this operation first, why don't we calculate the left and right side of this minus, all the different ways we can do that, and then we can do this operation. So in this case, for the left side, now we only have 2 times 3, which is 6, and for the right side, we only have this, which is 20. And then we can do the minus. And so doing the minus first would basically give you that, right? Because if you do the minus, then these two are separated, so it's basically putting parentheses like that. And so that's kind of the idea. We can basically just have an operation and say, if we do that, let's get a left results, let's get a right results, and let's get all combinations of performing our operation, in this case a minus, on the left and the right. And so let's actually add another number just to show. And also there's no divide, so you don't have to like worry about dividing by 0 and so on. But let's say we have one more operation, so it's like minus 3. So now we have, actually let's add 2 more numbers. Let's do 5 plus. Okay, so now let's say we choose to do this first again. So basically we're saying, okay, we're going to get these left results, and then we're going to get these right results, and then we're going to do this. So for this left result, we're going to focus on this subproblem here. And so for this subproblem, we can either do this first, which will give us 6 plus 5, right? And once again, here, we're going to choose to do which operation first. So if we choose to do this operation first, then we're going to say, okay, our subproblem now will be this and this. And our base case will be once we just have one number. So in this case, we'll just have the 3, and then here we'll say, okay, we'll do this operation, and this, and these two will be the base cases. But basically, that's kind of the idea is here we're going to say, okay, so the two ways to get this is either 5 plus 6 or 7 times 3. And so 5 plus 6 is 11, 7 times 3 is 21. And then the right side, same thing. So you can either do the multiply first or the minus first. And that's basically going to be every time. So basically what we're going to do is we're going to say, if we want to do an operation, we're going to do the subproblems first, get arrays of results, and then build up the whole thing. So in this case, we can either do 4 times 5 minus 3, so that'll be 20 minus 3, 17. Or we can do 4 times 5 minus 3 first, which will be 4 times 2, which will be 8. So 4 times, actually it'll be 5 minus 3 first, yeah, so 4, yeah, 8. And now, for this right side, these are the results that are possible, and for the left side, these are the results that are possible. So if we combine the two, we can have 11 minus 17, 11 minus 8, 21 minus 17, and 21 minus 8. And that is the result of doing this operation first. Then we have to do that for every single operation in the original problem. So we'll do this one first, this one first, this one first, this one first, this one first. And that's kind of the DP. So in the DP, we're going to track a couple things. So first of all, we're going to split our stuff into numbers and operations. So in this case, basically, here, let's actually use this one. So if it's this problem here, we're going to say our numbers are 5, 2, 3, 4, 5, 3. And our operations is this. So plus, times, minus, times, and minus. And then given an operation, it's really easy to know where to split, right? So basically the operation is for the number at the same index and the one after always. So like this minus is going to be for this 4 and this 5. This one's going to be for these 2 and so on. So we're going to split it into 2 arrays originally, and then we're going to keep track of the left number of our whole thing and the right number. So we'll start with this whole thing being available, and then when we choose an operation, let's say we choose the minus will be for, it'll be right over here right after these first 3. So then our subproblem will be this and this, and then we're going to do the minus. And then the base case is when the left and right is the same. Basically, you just have one number so you can return it. And then we can add memoization as well, because you will have a lot of like repeated work here. So imagine it's all pluses. Like imagine, I'm not going to change this, but let's say it's all pluses. So if I do 5 plus 2, and then I add 3 afterwards, or I do 2 plus 3 plus 5 afterwards, no matter what, I still have to do this whole section. And this whole section I can get to a bunch of different ways, right? So basically adding memorizations can be good. Okay, so let's take a look at the code. So we have the numbers, which is the numbers array. We have the operators array, which is like these pluses, minuses, whatever. And then we have our DP array. And our DP will be n squared because we have a left and a right for the numbers. So so this is our DP, but let's look at the other part first. So first we have 2 numbers and a symbol. So if we have a plus, we just return a plus. If we have a minus, we return a minus, and otherwise we return multiply. Then we parse our string into numbers and symbols, and that's pretty easy as well. Anytime we have a number, let's just keep adding to the number, and then anytime we have a symbol, then we put in a symbol. So that's basically here. If we have a digit, let's keep adding that. Otherwise, let's add the operator. So we'll have our numbers array and our symbols. Then we have the compute, which is like the DP. We have a left and right bound. And if we have a cached value, we can return that. If the left is equal to the right, this is the base case. So if this is the same, then just return that number. Otherwise, we have to go through all of the numbers that we have, and then we have to split our operation into 2 parts, right? So we go through all the numbers that we have, and then we split on that. So basically we'll do the operation up until the number and the operation after the number. And we're going to get this left part and the right part, and that's, if we choose like this minus as the middle, then the left part will be all the different ways we can do this half, and then the right part will do all different ways we can do this half. And then we basically have to do all combinations of that. So for every left, do a right, and then subtract them. Or not subtract them, in this case. Actually, I deleted accidentally. Okay. Yeah, so not subtract them, but use the actual like operation that we have, right? So we get the left, we get the right, we get the operation, and then we do this calculate, which uses the operation. And then we add it to the result, we cache it, and we return. Yeah, and then we just call this starting at the first number and the last number. And yeah. Okay. And so thinking about the runtime for this is kind of complicated, but so let's take a look at each part. So this calculate is O1, obviously. Parsing the expression is linear because we're just going through the thing once. The string, and it's only 20 characters. That's a nice thing. That's why you want to think about dimensions, because 20 characters, you can do something pretty inefficient. But then this DP thing is the thing that is actually a lot. So left and right is n squared already, because you can have any starting and ending value. Looping through is linear, but then this part is pretty big. Because the left part and the right part, there's basically 2 to the n combinations you can have for each. So like you can have 2 to the n here, and you can have 2 to the n here. So it's like 2 to the n times 2 to the n, I think. Yeah. Something like that, I think. Yeah, because basically at every single operation you can pick like which one do I do first. Yeah, so I think it's like, could be wrong about this, but I think it's something like this. 2 to the n. And the space, so same thing, I think. You can have n squared possible states, and then for each one of those you can have 2 to the n combinations. Yeah. Because the other way I think it is 2 to the n, because you can actually do this with a bit mask. So with a bit mask, you can turn on which operation you've used, right? So for all these operations, you can have like all zeros, and then you can turn them into 1. So that's another way to do it. If you don't want to have a left and a right, you can use a bit mask, I think. And then that would memoize more, but you can kind of truly see how many different things you can have, right? Because if you have a bit mask of number of operations you've used, the number of operations is n, and then the bit mask has 2 to the n states. So in that solution, you would just say, okay, I have some bit mask and some result. Actually, just the bit mask, and then you store the result for that. And then you just turn on one operation for that bit mask, I think. Something like that would probably work. Yeah. So I think that is it. So kind of a tough problem, to be honest, but the main thing to recognize is you don't really care about the parentheses. The main thing you care about is like, what operation do I do first? And the way to break it up is actually do the operation last, and then do the subproblems first, and then do the operation on all combinations. It's kind of like a build all combinations of binary trees, something like that, where you pick a node to be the root, you get all the possible left subtrees, all the possible right subtrees, and you combine them all at the root. Kind of a similar one, but definitely a tough problem, I think. And yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.